Hello students, very warm welcome once again to my YouTube channel. So today the topic is A to Z practice exercise of IUPAC nomenclature for class 11th. So it will be covering entire IUPAC nomenclature in a very simple way. So I will discuss so many examples on this topic. So about all the general rules of IUPAC nomenclature I have already discussed in my earlier videos, and link will be shared in the description box. So to understand this topic of IUPAC nomenclature for organic compounds, please watch my this present video and all earlier videos till the end to understand it. So now let's start with this topic of today's topic, A to Z practice IUPAC nomenclature. So I will be explaining it with the help of examples. So let me start this. Let me start with this first example. So this is the compound, and we have to write the IUPAC name for it. So first we can write this compound in this way. Here what I have done, this C2H5 I have written as CH3CH2. Basically both are same, only C2H5 as CH3CH2. So now what we have to do, we have to select the longest possible carbon atom chain. So all the rules I have discussed in my earlier videos, but again I will repeat. So in this case we have to select the longest possible chain of carbon atom which is containing functional group and maximum number of multiple bonds. So in this also we have to select the longest carbon atom chain which is having both the things, functional group as well as this double bond also. So we will number it like this, 1, 2, 3. Now because in this way it is containing this functional group also and the double bond also. So then I have given the numbering like this, 1, 2, 3. So in this way this will be the substituent. CH3CH2 will be the substituent, and we know very well it is called the ethyl group. So how will we write the name? So 2 position this substituent is there which will be written as a prefix. So 2 ethyl and 3 carbon atom chain is there. So prop 2 in position of double bond 1 all, because this OH group is present at the number 1 carbon atom. So this will be the name, 2 ethyl prop 2 in 1 all. So next example, this is very simple. So in this there is no substituent is there, but functional group is there and this double bond is also there. So how will we do the numbering? So in such cases where the functional group is also having the carbon atom, so while numbering of the parent carbon chain, we will consider the functional group carbon as the number 1 carbon. So in this case, this carboxylic acid, this will be the 1, 2, 3, 4. So no substituent, so no prefix, and 4 carbon atom chain is there. So but 2 in, and this in, ene because double bond is there, but when functional group is present, so this E is dropped out and it is simply written as En. So that is why I have written here En. So but 2 in 1 OH acid. So this position of this carboxylic acid is 1. So 1, and this functional group carboxylic acid as a functional group is written as oic acid. So this will be, the name for this will be but-2-in-1-oic acid. Okay. So then next example. So this is the next example. It is having this functional group, ketonic functional group, and this double bond. But here this carbon is having two CH3 groups attached to this. So we can write it in a simplified way. So here I have written it like this. So this portion is same, and this carbon I have written having this one CH3 group, and this is the second CH3 group. So numbering we will start from right to left, because then this functional group will get the lower numbering. So 1, 2, 3, 4, 5. So first we will write the substituent 4-methyl, 5 carbon atom chain, pent 3 in 2 on. So 2 is the position of the functional group, ketonic group, and when ketonic functional group is present, it is written as on as a suffix, as a secondary suffix. So name will be 4-methyl pent 3 in 2 on. Here also this aniline, last E is dropped out and it is simply written as En. So now the next example is this. So here this CN functional group is there and one double bond is there. Again numbering will be like this, 1, 2, 3. So no substituent. So prop 2 in 1 nitrile. So this CN functional group is added as nitrile as the suffix, as the secondary suffix. So name is prop 2 in 1 nitrile. So now let's move to the next example. Now coming to this example, so we have to write the IUPAC name for this compound. So we can see here it is having 2 carbon atoms. So then first we will do numbering 1, 2. So 2 carbon atoms and no substituent is there. So no prefix, because 2 carbon atoms, then it will have word root ethane, 1, 2 diol. Why diol? Because it is having only these 2 functional groups. 2 aldehydic functional groups are there. So for aldehyde, this al is added as the secondary suffix. So name will be ethane 1, 2 diol. So then next compound, this is the next compound. So first let us do the numbering 1, 2, 3, 4. So no substituents are there, so no prefix. So it is having 4 carbon parent chain is there, so it will be but 2-ine, because the position of the triple bond is at 2. 2-ine and 1,4-dioic acid. Because at number 1 carbon and number 4 carbon, 2 carboxylic acid groups are there. So that is why this dioic acid. Because for carboxylic acid functional group, suffix which is used is oic acid, and 2 carboxylic acid groups are there and the position is 1 and 4, so 1,4-dioic acid. So then to the next compound, this one. So here we can see this functional group is there. This is the ester functional group. So first, let us do the numbering for this, and this is the first, this is the ester group, so it is written as this, like this, COOR. And in place of this R, here we are having this methyl group. So numbering we will do like this, 1, 2 and 3. So in such cases where ester group is present as a functional group, so while writing the IUPAC name, first this R group is written at the starting of the name. So here we can see this R group is CH3 group, methyl group. So we will start the name for this compound by writing this methyl. So methyl, and then we will write the prefix. 2 position pe we are having methyl group, again methyl. So methyl, this methyl for this methyl group, then 2 methyl, 3 carbon atom chain. So this is prop 2 in 108. So this will be the name. So again I will repeat, because in this compound it is having this ester as a functional group, which we can write like this also, COOR. And for such compounds, when we write the IUPAC name, first this name of this R group is written first. So here this is the methyl group. So we will start like this, methyl, 2 methyl, prop 2 in 108. So for this ester group, in the end as a suffix, this OH is used as a secondary suffix. So this will be the name. So then this next compound, here we can see, first let's do the numbering, 1, 2, 3. Because always this, earlier also I have explained, wherever this OCH3 group is present. So this is called the OR, means OCH3, you can write it like this, OR also, and it is said the alkoxy group. So whenever this group is present, it is considered as a substituent. So in this case, we are having the functional group as the aldehyde group. So name will be 2-methoxy, 3 carbon atom parent chain. So 2-methoxy propan 1-al. 2-methoxy propan 1-al. So this L is used for the aldehyde group. So this will be the name. So now coming on to this compound. So this is a bit complicated compound. So first we will try to write it in the simpler way. So first let me write this. So this carbon, so basically this carbon is having 1 OH group, and this unit is attached to this carbon, and 3 units of this are attached to this carbon. So first let me write, so this carbon I have written here having 1 OH group, and these 3 units are attached to this same carbon. So what is this? This is having 1 CH which is attached to the other 2 methyl groups. So in this way we can write it. So 1 CH, this carbon is attached to 1 CH which is having 2 other methyl groups. Okay. So same unit I have to write it over here also. And same unit here also. So these 3 units are attached to the same carbon. So now what we will do, first we will do the numbering of the parent chain. So here we can see this will be the parent chain because it is having the functional group, which is this OH functional group is there. So this will be 1, 2, 3, 4, 5. So this is a 5 carbon atom parent chain. This is the functional group OH and this is the substituent. This is also a substituent and this is also a substituent. So first let us write the name of these substituent. So this substituent is the methyl group. This also methyl group. And for this branch substituent, so basically we can see this carbon is attached to the parent carbon chain. So this we will write the number 1 and this the 2. So here we can see this is the ethyl chain having one methyl group. So for this, what will be the name for this substituent? Name will be 1-methyl because one number carbon atom is having one methyl group, 1-methyl ethyl. So this will be the name for 1-methyl ethyl. This will be the name. So this 3 substituents are there. So they will be written in the form of prefix and in the alphabetical order. So first will come this and this. So what will be the name? We can see this substituent and this substituent position is 2 and 4. So name will be 2,4-dimethyl 2,4-dimethyl and this substituent is present at the 3rd number carbon. So 3 and then because this is a branch substituent, this name will be written in the bracket within bracket 1-methyl ethyl bracket close and then what will come? So after this, because this is a 5 carbon chain, so pen-10 3 position OH group is there, 3 all. So this will be the name. So first what we have to do, first we have to write this compound in a simplified way and then we have to give the numbering to the parent chain as I have done. So we can see this OH group is the functional group. This is the functional group and this parent chain is having 3 substituents, this, and this. So while writing the name, we will write 2,4-dimethyl 3 within bracket 1-methyl ethyl bracket close pentane 3 all because this all is used as the secondary suffix for the hydroxyl for the OH alcoholic group. The next is this compound. Okay. So this compound is written in the form of the bond line formula. So if we want, we can write it in the another way in the condensed formula form. So let me first write it in this condensed way. So this is the terminal carbon. This also is a terminal carbon. As earlier I have explained, these terminal carbon means that this is methyl group, CH3 group. So this is this methyl group and then going on CH, this carbon, it is attached with a double bond to this carbon and with this carbon again it is attached with a methyl group. This is a single bond and here it will be CH2 and this will be CN. So this I have written like this. So now we can do the numbering of this compound, because CN group, this is the functional group. So numbering we will start like this: 1, 2, 3, 4, 5. So now it is very easy to write the name. So 3 position we are having methyl group, 3 methyl, because 5 carbon atom chain, pent, 3 in 1 nitrile. So this will be the name. So once again I will repeat. So name will be 3 methyl pent 3 in 1 nitrile. Okay. So the next compound is, so here we can see this OH is the functional group, alcoholic functional group is there, and both these are methyl group and bromo group are the substituents. So numbering we will do like this: 1, 2, 3, 4, 5, 6. So we will write the substituents as a prefix in the alphabetical order. So this is the bromo group, this is the methyl group. So this bromo will come first. So name will be 3-bromo, 5-methyl, 5-methyl, 6 carbon chain, 6 carbon parent chain, hexane, 2 all. So this will be the name. Position of the alcoholic group is 2. So 2 all. All, OL, all is added as a secondary suffix for the alcoholic group. So now the next example is, this is, here we can see a different type of compound. Basically here this is a aliphatic chain which is having a functional group, chlorofunctional group at one end, and at another end we can see benzene ring is attached to it. So in such cases, this benzene ring is treated as a substituent, and the name which is used for this is called the phenyl. So we can say, while giving the IUPAC name, it is named as a phenyl derivative of that aliphatic compound. So both these are the substituents. Cl and phenyl both are the substituents. So their name, they will be written in the form of prefix. So, and in the alphabetical order. So first give the numbering to the parent chain. So we will start the numbering from left to right. Why? Because from left to right we can see this double bond will get the lower numbering. So now we can write the name. So this is the chloro group. So first we will write the chloro group. So chloro group will come first. So name will be 3-chloro, 1-phenyl, 1-phenyl, prop, 1-ene. 3-chloro, 1-phenyl, prop, 1-ene. So this will be the name. So the next example is this one. So it is very simple. We will do the numbering from left to right. 1, 2, 3, 4. So 2-chloro, but, 2-chloro, buta, 1,3-diene. 2-chloro, 4 carbon parent chain, buta, 1,3-diene. 2 double bonds are there, so 1,3-diene. So now in this example it is looking somewhat very complicated. So first we will write it in a simpler way. We will write it in the condensed formula form. So So we know this, this, this. These three are the terminal carbon atoms in the bond line formula. So all these three carbon will be CH3 in this case. So we can write it like this, CH3. So first let me give the numbering in this case. 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8 number carbon atom. This is the 7 number. So first let me write the parent chain. 6, 5. This will be CH2. This will be CH2. This is the 6 number carbon atom. This is the 5 number carbon atom. So here this will be CH. This is the 4 number carbon atom, and then 3 number carbon atom. This will be CH2, and here this will be C only, C, and then here it is CH3. So we can see this is the 4 number, 3 number, 2, 1. And coming on to this side, this will be CH2, CH2, and this will be CH3. So I have done numbering in this way from right to left. 1, 2, 3, 4, 5, 6, 7, 8. So if we go like this, so again 5, 6, 7, 8. So it will be same. In both ways it is having the 8 carbon atoms in the parent chain. So we can consider in any way. Now, so I have done like this. So now it has become very simple. So we can see this will be the substituent or the side chain, and the name for this will be, because it is the 3 carbon atom side chain, so name will be written propyl for this, propyl group. So name, what will be the name for this compound? 5-propyl. Name will be 5-propyl oct, because 8 carbon atom parent chain, oct 2 ine. 2 position पे triple bond is there, so that is why 2 ine. So if we get such compounds which are written in the bond line formula, so first we can write it in a simpler way, and then we can start with the numbering and then write the IUPAC name. So in this case 5-propyl oct 2 ine. So this will be the name. So now in this second type of questions that can be asked in your exam, okay, you have been given the IUPAC name of the compound, and you have to write the condensed and bond line structural formula of the compound. So let us understand with the help of the examples. So first let me write about the general rule for the IUPAC. So we have studied earlier also. This is prefix plus word root plus primary suffix plus secondary suffix. So we know prefix is the substituent, word root is the parent chain. How many carbon atoms are there in the parent chain? Primary suffix tells us about the compound, whether it is saturated or unsaturated, and secondary suffix tells us about the functional group in the compound. So let us see this first example. This IUPAC name is given 2-methyl buta-1,3-diene. So this 2-methyl is the prefix, and what is the word root here? This buta is the word root here. Buta word root means that this compound is having 4 carbon atoms in the parent chain. So first let me write like this. I can write like this 4 carbon atom chain I can write. It is like this. Okay. So then if I write the number 1, 2, 3, 4. So then here we can see 2 methyl means 2 number of carbon is having the 1 methyl group. 1, 3 diene. 2 double bonds are there and the position for them is first is at the first carbon atom and second is at the third carbon atom. So this is the 2 double bonds are there. Now here we can see, as we know, carbon is tetravalent, so it has 4 valencies. So here we have to see whether all the 4 valencies of carbon is satisfied or not. So in this carbon number, first carbon atom, here we can see 1 double bond is there. So it will be CH2. In case of C2 carbon, 2 single bonds, 1 double bond. Valency is complete. C3 carbon, 1 double bond, 1 single bond. So here it will have 1 CH. For C4, 1 double bond. So it will be CH2. So this will be the condensed formula for this compound. And if we write the bond line structural formula, so how can we write? So first I will write carbon number 1 and 2. So if we write 1 and 2, so it is like this. Carbon 1, 2. There is a double bond between both of them. And then here C2, C3. So this is C3, C4. So there is a double bond between C3 and C4. This is the double bond. C3 and C2 single bond, C2 and C1 double bond. And at C2, 1 methyl group is there which can be written like this. So this will be the bond line structural formula in this case. So now moving on to the next example. So here it is hexa 1,3,5 triene. So we can see here there is no substituent. No prefix in the name means no substituent. And here hexa, this hexa is the word root. Means this compound is having 6 carbon atoms. So first let me write 6 carbon atoms. So this is 6 carbon atoms. 1, 2, 3, 4, 5, 6. No substituents are there. 1, 3, 5 triene means 3 double bonds are there and the position is number 1, number 3 and number 5. So this is the position. Now we can write the hydrogen atoms and how we are going to write it. So let's see. This carbon having 1 double bond, so this will be CH2. This C2, 1 double bond, 1 single bond, this will be CH. C3, 1 double bond, 1 single bond, CH. C4, 1 double bond, 1 single bond, this will also CH. Here also it is same, and for C6 it will be CH2. Now we can see all the carbons are having all the 4 valencies satisfied. So for the bond line formula in this case, 6 carbon atoms are there. So first write it like this: 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. Double bond between C1, C2, then C3, C4, then C5, C6. So this will be the bond line formula for this. So now moving on to the next example. 3-ethyl penta 1,3 diene. So 3-ethyl, this is a substituent. And this penta is the parent chain. Parent chain having the 5 carbon atoms. So first let me write 5 carbon atom chain. 2, 3, 4, 5. And then numbering 1, 2, 3, 4, 5. 3 C3 having 1 methyl group. 2 double bonds are there and the position is 1 and 3. This is 1, this is 3. So now we can complete it. CH2, this will be CH. All the 4 are satisfied. Here CH and this will be CH3. This is 3-ethyl. 3-ethyl means CH2, CH3. Ethyl, we know ethyl group is C2H5. This is the ethyl group. So we can write this ethyl as CH2, CH3 also. Okay. So, and isko we can write it in the another way also. We can write it like this. In place of this chain, we can write C2H5 also in condensed structural formula. So this is the another way. So for bond line structural formula, again first write 5 carbon chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. C1, C2 double bond, C3, C4 double bond, and that's C3. This 3 carbon atom, it is having the ethyl group. Ethyl group means it will be written like this. So ethyl group will be written like this. So this will be the bond line formula for this compound. So now moving on to the next compound, we can see this is very long name of this organic compound, but we will write the formula for this. So 2-hydroxy, this is the substituent, and propane. Propane, this is the parent chain. Means parent chain is having the 3 carbon atoms. So first let me write 1, 2, 3. This is the 3 carbon atom and numbering 1, 2, 3. 2 carbon atom position pe we are having 2-hydroxy. And then propane 1, 2, 3 tricarboxylic acid. Means all the 3 carbon 1, 2, 3 are having 1 COH group. So we will write like this. Here COH, here COOH, here also COOH. Now we can write the hydrogen atom. So here it will be having CH2. Here all 4 valencies are fulfilled. Here will be CH2. So this will be the condensed formula for this compound, and even it can be written like this. Suppose we can write it like this: CH2 COOH. So this is the 3rd number carbon atom. So after this will come the 2nd number carbon atom, and this 2nd number carbon atom is having 1 OH group, bracket we will write it like this, 1 COH group like this. And then comes the number 1 carbon atom, which is attached to 1 COOH group. So this is the number 1 carbon atom. So it can be written in the condensed way like this also. Now coming to the bond line formula. So first write 3 carbon atom parent chain. So it is like this. Okay, so this is the number 1 carbon, number 2 carbon, and number 3 carbon. So first number carbon is attached to 1 COH group. So it will be written simply like this. And 2 number carbon is having 1 COH group and 1 OH group. So it will be represented like this. And C3 is having one COOH group. So like this. So and then further we have to identify the functional group also in this case. So we can see two functional groups are there. So first is the COOH group, which is for the carboxyl group. And second functional group, OH group, is also there, which is called the hydroxyl group. So this is about the functional group. So now moving on to the next compound, hexane diol. Hexane means it is having the 6 carbon atoms. So first we can write like this: 2, 3, 4, 5, 6. 6 carbon atoms. And we know if this al is added for the aldehyde group, for this aldehyde group, this al is added. So because here position is not given of the aldehyde group, means, and diol means 2 aldehyde groups are present. It means both the aldehyde groups are present at the 2 ends of the compound, one here and another one here. So, and we know very well the functional group which are having the carbon atom, those carbon atoms are also counted in the parent chain. So we will do numbering like this: 1, 2, 3, 4, 5, 6. Now we can write the hydrogen atoms over here. CH2, it will be CH2, this CH2, this will be CH2. So this will be the name, this will be the condensed formula. It can be written much in a more simplified way. Here we can see there is a repetition of CH2. 4 times CH2 is there. So we can write it simply like this: 4 times CH2, and here this is CHO, and here also there is CHO. So this way also we can write. Now for the bond line formula, let us first write 6 carbon atom chain. 1, 2, 3, 4, 5, 6. And one end, this is CHO. 1, 2, 3, 4, 5, 6. This is also CHO. So this will be the bond line formula, and it is having aldehyde group, only one functional group, and that is the aldehyde group, CHO group, which we call it aldehyde group. Aldehyde group. So now I am going to discuss with you about how to write the IUPAC name for the compounds which are having more than one functional group, means polyfunctional compounds. So this is the first case. Here we can see 2 functional groups are there, OH group and NO2 group. So, but as I have discussed earlier also, whenever this nitro NO2 group is present, it is considered as a substituent. So in this case, we will have 2 substituents, nitro group and this methyl group, and OH will be the functional group. So first we will do the numbering of the parent chain, and then we will write the IUPAC name. This is the methyl group, this is the nitro group. So they will be written as a prefix in the alphabetical order. So methyl will be written first. So 2 methyl, 4 nitro, pent 5 carbon atom parent chain, pentane, 2 all. So 2 methyl, 4 nitro, pent 2 all. This will be the name. So now moving on to the next compound. Here we can see two functional groups are there. This cyanide functional group CN and one OH functional group is there. Now in such cases, what we have to do, as I discussed earlier also, there is a priority table, now, which I discussed with you earlier. In this priority table, we have to see the position of both these groups, CN group and the OH group. So here we can see this is the CN group, which is above the OH group. This is the OH group. So because CN group is above the OH group in the priority table, so this CN group will be considered as the principal functional group, and this OH will be treated as the substituent. Okay. So then in this case, this CN group will be the principal functional group. This will be the principal functional group, and this OH and this CH3 both will be the substituents. Now, so first let us do the numbering. 1, 2, 3, 4, 5. So name will be, first this methyl group will come after, in alphabetical order we have to write the name. So first this hydroxy group, then methyl group will come. So name will be 3-hydroxy 4-methyl pent 4-in-1-nitrile. So this will be the name. So alphabetical order we have to write the substituent 3-hydroxy 4-methyl pent 4-in-1-nitrile. So this nitrile is added as a secondary suffix in case of CN functional group. So this will be the name. So next example we can see. So in this example also, COH and CONH2, these two functional groups are there. So according to the priority table, this COH group will be the principal functional group, and this CONH2 will be the substituent. So here there is one thing to note here, that whenever this CONH2 amide group is present as the substituent, so then how it is written? Then it is written in the form of prefix, and this CONH2 is written as carbamoyl. So this CONH2 is written as carbamoyl in the form of prefix. Okay, so this is we have to remember. Now, so then only we will be able to write. So name will be first let me give the numbering. This will be the numbering, and name will be 2. This 2-carbamoyl propanoic acid. This will be the name. So 2-carbamoyl propanoic acid, because for carboxylic acid as a functional group, principal functional group, oic acid is used in the form of secondary suffix. So this is the another example. So in this case we can see all these three functional groups are same. So then what we will do? We will do the numbering like this: 1, 2, 3. So how can we write the name? Because this is a 3-carbon atom parent chain, so we will write propane. Propane 1, 2, 3 tricarboxylic acid. So this will be the name. Propane, because all three functional groups are same. So we will write the name like this: propane 1,2,3 tricarboxylic acid. So this next example is, here we can see it is same as the earlier one. Only difference is there that this carbon is also having one aldehydic group. So in this case, we will consider this as a parent chain. We will include this one and this one carboxylic acid also in the parent chain, and numbering we will do like this: 1, 2, 3, 4, 5. So both these will be the substituents. These will be the substituent, and this will be the principal functional group. And both these will be the substituent. And whenever this CHO group is present as the substituent, the formyl word is used for this as a prefix. So we write it as a formyl. And this carboxylic COH group is written as the carboxy as a substituent. So here I will write it: prefix. If CHO group is there, then formyl is used. If COH group is there, then carboxy is used as a prefix. So what will be the name? Name will be 3-carboxy. Both are the substituent. So carboxy will be written first because of the alphabetical order. 3-carboxy, 3-formyl, 5-carbon atom chain, pentane, 1,5-dioic acid. 3-carboxy, 3-formyl, pentane, 1,5-dioic acid, because two COH groups are present at 1 and 5 carbon atom in the parent chain. So that is why 1. So now coming on to the next example. So here we can see this NH2 and CO. Both these functional groups are there, but according to the priority table, CO ketonic group will be the principal functional group. So we will first do the numbering. So we will numbering in this case start like this: 1, 2, 3, 4, 5. So both these are the substituents. This NH2 and this methyl group are the substituents. So their name again will be written in the alphabetical order. So name will be 5-amino. So if NH2 group is present as the substituent, so then amino word is used here. 5-amino, 3-methyl, pentane, 2-O. So 5-amino, 3-methyl, 5-carbon atom parent chain, pentane, 2-O. This is the position of the ketonic group, and O-N-E-on is used in case of ketone as a secondary suffix. Now coming on to the next example. So here we can see this CHO group is there and this NHCH3 is there. So this will be the principal functional group, aldehydic group, and both these will be the substituent. So first let me give the numbering: 1, 2, 3, 4. So 4 carbon atom parent chain is there. This is one substituent, this is second substituent, and this is the third substituent. So this is the methyl group, and this we can say this is the ethyl, and this, because we know NH2 is the amino group, and here one H in this NH2 is replaced by CH3 group. So this will be named as N. So this will be named as N-methyl amino. So this substituent name will be N-methyl amino. So name, what will be the IUPAC name? So, and these substituent in alphabetical order we have to write. So 2-ethyl, this will be the number 1, this will be number 2, and this will be number 3. 2-ethyl, 2-methyl, and then position of the substituent is 4 within bracket N-methyl amine, bracket close, butanol. So again I will repeat. So this will be the parent chain. CHO group will be the principal functional group. So 3 substituents are there. This is the ethyl group, this is methyl, and this is the N-methyl amino group. So name will be 2-ethyl, 2-methyl, 4-N-methyl amino butanol. Butanol, al because aldehyde group is the, because aldehyde is the functional group. So this will be the name. So next example we can see here. So this is written in the bond line form. So there is nothing to worry. So we can first do the numbering. So from where we will start the numbering? From left to right, because this functional group will get the lower numbering. So in this way we will do the numbering. 7 carbon atom chain is there. So then it is very simple. 4-methyl. 7 carbon atom chain, so hept 5 in, 5 position double bond, 5 in, 2 on, 2 position pe this ketonic group is there. So name will be 4-methyl hept 5 in, 2 on. For ketonic group, this ONE on is added. So now in this case, so here first let us do the numbering. So numbering we will do like this: 1, 2, 3, 4, 5, 6. So here we can see on this is the principal functional group. OH is the principal functional group, and here this is the terminal carbon, terminal carbon, terminal carbon. So these will be the methyl groups. It means this, all are the methyl groups. So while writing the name, we will write 3,3,3,5. 3,3,5 trimethyl. 3 methyl groups are there. Trimethyl hex, 6 carbon chain, hex 1 in 2 all. So again I will repeat 3,3,5. So we know these are the terminal carbon atoms 1, 2, 3. Means they are the CH3. 3 methyl groups are there. So 3,3,5 trimethyl hex, 6 carbon atom parent chain, hex 1 in 2 all. So this will be the name in this case. So now coming on to the next example. So here we can see, so first let us do the numbering. So numbering will be done from left to right. 1, 2, 3, 4. So first, because here it is written C2 at 5. So we can write it in this way also. Let me write. This C2H5 we can write it like this: CH2, CH3. So now numbering 1, 2, 3, 4, 5. So this will be the numbering. So this I can remove because, so this will be the numbering, and this is a cyclopropyl ring. 3 carbon atom cyclic ring is there. So this is called the cyclopropyl ring. So this will be treated as the substituent, and this is another substituent. So the name will be, first cyclopropyl will be written 1-cyclopropyl 3-methyl pent, 5 carbon atom parent chain, pent 1-ene. So while numbering will be from left to right, and number 1 carbon having 1 cyclopropyl ring as a substituent. So 1-cyclopropyl 3-methyl pent 1-ene. So this will be the name. So now the next example is the cyclic organic compound. So in this, 1 ketonic group is there, 1 carboxylic acid group, and 1 aldehydic group. So among all these groups, first let us decide which will be the principal functional group. So according to the priority table, this COH group comes on the top of the priority table. So what we will do, this COH group will be treated as the principal functional group, and both these, this ketonic group, aldehydic group, will be the substituents in this case. So okay, so and these both of them will be written in the form of prefix. So let us discuss for this ketonic group. This is the ketonic group. We use oxo. We use oxo as a prefix when it is present as the substituent. Okay. And for this aldehydic group, we use formyl. Formyl is used as a prefix. So what we will do, first numbering we will do. So numbering will be done like this: 1, 2, 3, 4, 5, 6. So name will be according to the alphabetical order. First this formyl will come. So 4 formyl, 2 oxo, cyclohexanoic acid. So let me explain it once again. So here 3 functional groups are present: carboxylic acid, ketonic group, and aldehydic group. So first we will decide which will be the principal functional group. So as we know, this carboxylic acid group is at the top of the priority table. So this will be the principal functional group, and both these will be considered as the substituents. And when this ketonic group is present as the substituent, this oxo word is used as a prefix. And in case of aldehydic group as a substituent, this formyl word is used as a prefix. So then we will write the name like this: 4 formyl. It will be written in the alphabetical order: 4 formyl, 2 oxo, cyclohexanoic acid. Cyclohexanoic acid, oic acid, because this principal functional group COH is there, so oic acid is used. Cyclohexane because it is a cyclic compound. Okay, hope it is clear. So now coming on to the next compound. So this is again the another compound. So first we have to give the numbering. So we will do the numbering like this from this carbon. Like this, 1, 2, 3, 4, 5, 6. Because if we start with this carbon, so then we will have on C2 we will have one side chain, C3 we will have one substituent, and they will get the lower number. So we will do the numbering like this only. So we know this is the methyl group. Terminal carbon, this is the methyl group, and this we can discuss first. Okay, we know very well CH2 double bond CH2. What is this? This is ethene. This is called ethene. And when one hydrogen is removed from this, so what we will get? CH2 double bond CH. And this will be one hydrogen is removed from this. So then we call it ethenyl. So then it is called ethenyl. Okay, so this is ethene, CH2 double bond CH2, and when we remove one hydrogen from this, then it becomes CH2 double bond CH, and this is called ethenyl. So this we can see, this chain is this same. This is the ethenyl. Ethenyl substituent is there. So while writing the name, what will be the name? So this we say, we are saying this is the ethenyl group and this is the methyl group. This is the methyl group. So name, first this ethenyl group will come. So name will be 2-ethenyl 3-methyl cyclohexa 1,3-diene. So this will be the name. So again I will repeat. So numbering we will do like this: 1, 2, 3, 4, 5, 6. 2 position, as I have discussed, this is the ethenyl group, and 3 position, this is the methyl group. So name will be 2-ethenyl 3-methyl cyclohexa 1,3-diene. So this will be the name in. So now I am going to discuss about if the name is given and you have to draw the structure of the compound. So here we can see this first example. Name is given orthoethyl anisole. So I have discussed in my earlier video about all these type of compounds. So first here we can see this anisole. Anisole is written. So what is anisole? Let us recall what is anisole. Anisole means when benzene ring is having one OCH3 group. This is called the anisole. Okay, orthoethyl anisole. It means ortho, as I told you earlier, ortho means if we give OCH3, this OCH3 number 1, so then this ortho position means this position number of number 2 carbon. So this ethyl group is present at this number 2 carbon atom. So this is the orthoethyl anisole. Okay, so another name we can also write for this is 2-ethyl anisole. Okay, so and then next example, this is para-nitroaniline. So what is aniline? So here we can see this is the aniline. So what is aniline? First, So aniline is when benzene ring is having one NH2 group. This is called aniline. Suppose we give this number 1. Now, so, and then here we have to write the structure of para-nitroaniline. Para means, what does it mean by para? Para means if the two substituents are present at 1 and 4 number position. Means this NH2 is at 1 number position, so 4 number position, this will be the 4 number position. This nitro group should be present at this 4 number carbon atom. So this is the para-nitroaniline, and we can write this as 4-nitroaniline. So it can be written like this also, 4-nitroaniline. So now the next example, now the next is 4, this name is written 4-ethyl, 1-fluoro, 2-nitrobenzene. Okay, so this is a bit complicated. So first let us draw the benzene ring here. It is saying at the 1C1, 1 number carbon, fluoro group is present. Suppose this is number 1, fluoro. So here we can write the numbering 1, 2, 3, 4, 5, 6. 1 fluoro, 2 nitro, 4 ethyl. Ethyl group is C2H5. So this is the structure of this. So 4 ethyl, 4 position this ethyl group, 1 fluoro, 2 nitrobenzene. So this will be the structure. This is the another compound. Here we can see the name is written 3-hydroxy 4-phenyl-butanol. So first let us see this butanol. This is about the parent compound. Okay, it is having the 4 carbon atoms. So I have written this 1, 2, 3, 4 carbon atom parent chain, and butanol means the number 1 carbon atom is the aldehyde group, because we know the functional groups having the carbon atom are also counted in the parent chain. So numbering if we do, it will be like this 1, 2, 3, 4. So then we can see 3-hydroxy means OH group is present at the C3 and 4-phenyl. So if you remember where this phenyl word is used, it is used when the benzene ring is attached to the aliphatic parent chain. So then for this benzene ring, this phenyl word is used. So here it is written 4-phenyl means at C4 one benzene ring is attached. So it is like this. So now let us complete the valencies of all the carbon atoms. So C2 will be CH2. Then all the 4 valencies are satisfied. This here will be CH and this will be CH2. So now 3-hydroxy 4-phenyl-butanol. So this will be the structure of this compound. So thank you so much for watching this video. I hope it would be really very helpful to all of you to understand this IUPAC nomenclature entirely. So now I will be covering the other topics one by one of the general organic chemistry for 11th class in my other future videos. So thank you so much. Thank you and have a great day.